Hello everyone, welcome to Hacker Heap. In this video, we will look into solving the problem sum root to leaf numbers. So before we start, please do like and subscribe to the channel Hacker Heap. So let's look into the problem. Given a binary tree containing digits 0 to 9, only each root to leaf path could represent a number. An example is root to leaf path 1, 2, 3, which represents number 1, 2, 3. Find the total sum of all root to leaf numbers. So in this given example, it clearly says, so we need to find the sum of 1 and 2 and 1 and 3. That will be 12 plus 13 should be 25. So if you look into a different tree like 1, 2, 3, 4, 5, we should be returning the sum of 1, 2, 3 plus 1, 4, 5, which should be 8, 6, 2, 268. That's how we need to do it. So if you look closely into it, all we are doing here is the depth first search. So we are going numbers by depth, and we will have the number when there are no nodes. We will add that number to the total sum. So let's look into what I'm saying. So we have this. Let's take the simple base case scenario of 1, 2 and 3 and also 1. Let's say the tree is just 1. We will check. Initially the sum will be 0. We will check if there are any right and left nodes. In this case, there are no right and left nodes. So we will be adding sum plus node dot value, which is 1, and we would return 1 in this case. So if you have the tree 1 and 3, all we need to do is we need to call recursively, and we need to, like every time, if there is a node, what we do is we will add the sum, add the number start 10 plus the value node dot value, so that in this case we had 1 already as a number, and when 2 comes in place, we will do 1 start 10 plus 2 until there are no nodes. So the sum at the end of this, when there are no nodes, is sum is equal to 12. And remember, we are doing a depth first search, so we go and find out the depth of this side, and once we are done, we will come here at this point where we will have 13. We will add sum plus 13. Sum is already 12. 12 plus 13 would be 25. All we are doing is a depth first search, nothing more than that. Let's go ahead and see how it looks in code. Let's say if root equal to null, we are just written 0. From here, all we are passing is the root 0, 0, where the number and the sum. Let's go ahead and write the DFS function, which we need to do. All we need to do is return public int DFS of tree node root number int number and int sum. Okay. If root is equal to null in this case, we would just return sum. If root dot left is equal to null and root dot right is equal to null, all we are doing is we would just return sum plus equal to num. Before this, as we talked, we need to add the number. Num is equal to num star 10 plus the root dot val. Alrighty. So now this is done. These are the base case scenarios. Now we need to call it recursively and just return the value. So we need to find the left child path and the number on the right child path. All we need to do is DFS of root dot left comma num comma sum plus DFS of root dot right comma num comma sum. That should be it, and we'll be returning that. Let's run the code. Alright, let's submit it. Yeah, it went through. So let's pass through the code what we have written here. Let's take a little bit complex problem. 1, 2 and 3 it has a 4, 5 and 6. So in this case, the sum should be 1, 2, 3 plus 1, 2, 4 plus 1, 5, 6, which should be 403. How do we get these nodes? That's where we are doing this DFS. So initially, we will be passing the root 1, 0, 0. In this case, root is not equal to null. And what we are doing is num is still 0 in this case. So we are getting the value of that. So in this case, it would be 1. Let me write it down here. Num is still 1. Root.left is not equal to null and root.right is not equal to null. So we will perform this operation where DFS of root.12. So in this case, it would be 2, 1, sum is still 0. We haven't added anything to the sum. Now here it comes here. Now the num becomes in the second iteration, it would become 12. And again, we will be calling it. And 3 goes this time and the number becomes 3. And root.left is equal to null and right is equal to null. So we added sum. Sum is now 123 at this point. So now in the recursive call, in the second recursive call, when it is 12, we just perform this. Now this will go ahead and happen. In this case, it would become, num would become 124 for the second recursive call. Remember, it will store the values in the recursive memory. So 12 will still be there and it added 124. And for this, root is equal to null and root.right is equal to null. So it adds to the sum. Now sum becomes 247. Now all this is done. It goes back. And when num is still 1, we haven't performed this yet. So it comes this way, 5. It doesn't have any left. So it goes to 6 and the number becomes 156. And now again it comes here. It adds to the sum. 156. In this case, it would be 3101,403. Now everything is null. All we are returning is the left side and the right side. So it would return 403 in this case. I hope it's clear. Please do like and subscribe to the channel. Thank you for watching.